So I'm here. I have a different background. I'm in my kitchen because my light went out. Excuse my phone. My light went out in the other room. So I'm here for right now. We are filling out these notes. I'm kind of small. Let me make it bigger. A little bit bigger. Okay. You have this paper. It says, oh, you're on this side. It says electromagnetic spectrum notes on the top. And then you're starting in that first column and it's going to say energy from the sun, just like our slide over here says energy from the sun. You need to have your paper. You need to be filling it out. And once again, you need to be able to hear me. And please do not stop watching the video whenever you find the last word that you need to write. I'm teaching you right now. I'm teaching you. And so it's not just about finding those words. Finding those words is very important, but I have important things to say to you all throughout the video. Watch patiently, follow along, fill in the blanks as you go. All right, so with your paper in hand, we're going to go through these slides together quickly. Energy from the sun. So we're talking about the electromagnetic spectrum. Almost all of the energy on Earth comes from the sun originally. It's coming from the sun. Okay, the light and the heat, that is turning into all these other forms of energy. If you think about it, we can talk about gasoline or coal. Those things were made of, we call them fossil fuels. They're made of those ancient plants that were turned into those things, and now we burn them. We're still releasing energy that was brought from the sun millions of years ago, even in those cases. The sun is a source of pretty much all the energy on the earth, okay? It's what allows life to exist. It's what lets plants live, animals, because animals all ultimately eat plants, even those that only eat meat. Say that I'm a lion and I only eat gazelles. What did the gazelle eat? Grass, right? So we have to remember that the entire food chain is based on plants as food. And the heat that we need to survive is also coming from the sun. Here's kind of a quick image of that electromagnetic spectrum, okay? It has red is the longest and violet is the shortest, okay? So the energy that's transferred to us from the sun travels to Earth as an electromagnetic wave. That's just what it's called, okay? So energy and light waves travel through space. They don't have to have stuff to travel through like atmosphere. They can travel through space. This is different than sound because if I was out in space with no space helmet, but it didn't kill me somehow, like just imagine, or something explodes in space, there's no sound. Because sound is vibrations of stuff. My voice right now is vibrating the air, okay? And then the little tiny things in your ears are vibrating when they capture that sound. There has to be something there for sound to go through. Light and energy doesn't need that in terms of the electromagnetic spectrum. It can go through the vacuum of space. Okay? Apologies if you can hear my fridge running. So here's a spectrum. A spectrum means a wide range. Okay? That things can be very different but still considered inside of this thing because of something they have in common. A diagram that shows all the different types of waves of energy from the sun, that is our electromagnetic spectrum. They are different because of their wavelengths. See how on the red side, they're really long, and on the violet side, they're really small and tight and together, okay? So we have the visible part of the spectrum, which is kind of in the middle here, and then infrared is over here. That means stuff we can't see, but it's still there, and ultraviolet we can't see, but it's still there. And ultraviolet is the part of the spectrum that gives you a sunburn, right? Or does damage to our skin, okay? That we need to protect ourselves from because it has a lot of energy, which you can see. I wonder if I can go back, but you can see because of look how many are close together under this ultraviolet area compared to what we can see. So you can think of it as having more energy, and that's why it does more damage to us, okay? The wavelength is how far between those two waves, okay? And so look again, this long wavelength and these short wavelengths. Sorry. So when heat or light is transferred as waves, we call it radiation. So this is important. Sunlight is radiation. Some people are like, are microwaves bad? Like, they use radiation. The sun that you love to feel on your face is radiation. The heat in your oven is radiation. The heat from a campfire is radiation. Radio waves for the radio in the car is radiation. Bluetooth for your AirPods is radiation. We call all of this radiation because it radiates, okay? It's just what we call that kind of movement of waves, okay? Most of what comes from the sun is visible light. Visible light is that color spectrum that we see, the whole rainbow. Invisible light, we usually are going to feel as heat, that our longer infrared is heat. If you've ever seen a lot of things on YouTube now show things with an infrared camera, that's heat, right? But that's not the only kind of light we can't see, okay? So visible light is the only band we can see, and it has that Roy G. Biv, right, for our rainbow. Red is the longest wavelength. You can almost think of it as the slowest. And then purple looks the fastest, or violet looks the fastest, the shortest. Okay? So it helps us understand images and colors and understand what's going on. Like, I can look at something green and I can make a guess about what it would taste like if it's a food, right? Or what it is. Our eyes being able to take that light and understand the colors of it gives us such an advantage of survival to understand what's around us and what's going on. Okay? Now again, ultraviolet is the kind that we can't see, that's shorter, and this gets us a sunburn. Okay? And it's when you get that sunburn, it's doing damage to your DNA, and that's why it can cause you to get skin cancer in the long term. Ultraviolet is mostly absorbed by the atmosphere, thankfully, but some still gets through. Now, we need a little, okay? We need just a little, because it helps our body make vitamin D, which helps our bones stay strong and our immune system work well, but we don't need much. That's like a few minutes in the sun each day. We still should wear sunscreen to protect ourselves from it for the rest of the time. Now, on your sheet, this says, fill in your electromagnetic spectrum. It might be really light. I know I had a problem with the copier, but that's why it's up here now, so you can fill all of that in. Fill in all of this information, okay? Again, visible light is what you can only see. Ultraviolet helps us with vitamin D, but it also gives us sunburn. And by the way, even if you have on sunblock, some UV will get through, so you can still make your vitamin D. And it helps our body. It can also kill bacteria. That's how strong it is. You might have seen UV like disinfecting lights, okay? There's more energy on the violet end and less energy on the red and infrared end, okay? So we can see, you need to write in these words, shorter wavelengths, higher frequency. Frequency, how frequent, how many per second or minute, okay? Infrared is heat or warmth. If I put an infrared camera, it'll show like the reddest parts or the warmest parts and the bluest parts or the coldest parts, okay? Has less energy, longer wavelengths, and a lower frequency, okay? Less waves in a second. Okay, let me go back for a second so you can pause. So pause if you need to fill it in. Okay. And here we are. So this is what you should have learned today, that you can explain the importance of the sun in the formation of most energy sources on Earth, knowing that without that sunlight, basically all the energy floating around in our world came from the sun originally, and that you can compare and contrast these different types of energy. Like here, you know the difference. And by the way, we didn't get into microwaves, but that's what's in a microwave. Radio waves, that's what's in all these technologies. Gamma rays are used for some medical treatments, especially to kill cancer cells. And X-rays, you know what X-rays are. They can go through the soft parts of your body, but get stopped by the hard parts. And that's how we get a clear picture of your skeleton from an X-ray. Okay, so you should be able to describe the differences between all these things. And that's that paper sorted. Now, hold on a second just so I can show you. The next paper you will get should be this. These doodle notes. Okay? And there's questions on the back. Yes, you need to answer the questions. Yes, we will go over them together. And where do these papers go? And this will be in Canvas. It's the next thing in Canvas. It's the next thing in Canvas. It's called Doodle Notes. Where do these papers go? In your binder. All right, keep working. Have a great day. And I hope you learned something.